Okay, so we will start with ASM today. ASM stands for Automatic Storage Management. So this S is for Automatic Storage Management, C-O-R-A-G-E. Now, before we start ASM, I think ASM is, from where I look at it, it's not a very complicated concept. If you know the history of it. So let me go a little bit, back in some older days and tell you what usually typical DBA would do if ASM would not have been there. So for that we need to understand something from the system administration point of view. So let us talk about an example where this is your hard disk, and on hard disk there is one file. This is your data file, and in that data file there is one extent, another extent, and so on and so on. Now let us say there is one very huge table, table A. So this is the first extent, this is the second extent, third extent, fourth extent, and so on and so on. And then this data file is totally full. When the data file is full, what's going to happen? Extent will be allocated in the next data file, and the next data file is also on the same disk. Let us say this is the C drive of your computer. Now just think of it. If you write a query something like this, select even count star, C-O-U-N-T, count star from table A. If you write this query, what is going to happen? If there is no index or anything like that, a full table scan is going to happen. Full table scan means to find out how many rows are there in a table, you have to read each and every block in that table, and you have to bring all those blocks into the buffer cache. So obviously there is a lot of disk I/O that is going to happen. All the blocks will be read and brought it into the SGA in the buffer cache. So let us say there are 1000 blocks for this table. So if these blocks are in one file which is sitting on one drive, then obviously what is going to happen, the spindle of that drive, it is going to spin, and then based on the RPM speed, these days there are 7200 RPMs, even 15,000 RPM disks are also there, revolutions per minute. So if the RPM is very high, then the speed at which we are reading blocks and bringing it into the buffer cache is going to be very fast when the speed is low. But the bottom line here is, when a query like this happens, there is going to be a full table scan. So there are certain situations where we cannot avoid a full table scan, even if we have created index when there are joins, especially when we do outer joins. The moment we do an outer join, all the indexes are kind of ignored and a full table scan happens. And outer join has to be done sometimes to get the reports that we like. So consider a situation of a full table scan. I/O cannot be reduced, and when the I/O cannot be reduced, then what can be done? To do anything, what we do, or what we used to do, is actually split the table space on two different disks. So one data file of that table space is here, and another data file of the same table space is somewhere else on a different drive. Okay, I'm not talking about a partition, it's on a different drive, so it has a different RPM and all that stuff. So what is going to happen? The half of the blocks of this table are going to be 50% of the blocks, assuming that part is here and part of them are now distributed. What will happen? A full table scan will take exactly half the time, because 500 blocks will be read from here and 500 blocks will be read from here, and since these two are separate individuals, they will start doing the work at the same time, and therefore the work will be done in half the time. It's like this, our typical old question: if it takes one person 10 days to build a wall, how many days will it take for two people to build the same wall? And the answer is obviously 5. Okay, so exactly half the blocks are read from this, half the block are read from this. So I/O is, even though it is a full table scan, it is doing actually a faster speed, and this is the advantage of actually distributing the I/O. So the whole purpose of implementing ASM that we're going to talk about is to do, number one, distribute the I/O. So many people say, let us implement ASM and increase the performance. My question to them, is your system I/O bound? I/O bound means, is the problem in your system related to disk I/O? If the problem in your system is not related to disk I/O, and if it is related to CPU, then ASM is not going to give you any performance improvement. Okay, so there are going to be always three situations in your database. One is the CPU problem, the second one is the IO problem, and the third one is going to be the memory problem. Everything boils down to the same thing, performance tuning. Finally, you have to identify whether it's a CPU bound issue, whether it's an IO bound issue or a memory bound issue, and sometimes it is a network related issue, and those things are something that we cannot even work into. For some people say that my select statement is taking a long time, but why? It's because everything is fast on the server. It's just your network from your point to our server is too slow. So all the performance related issues, they finally boil down to this, and ASM is gonna help you only if it is a IO bound issue. Memory bound issues and CPU related issues cannot be resolved by ASM. So how do we start with ASM? First thing is that ASM does is it will distribute the IO. So obviously you will need multiple disks, and you need to split your data into multiple disks, and then you will distribute the IO. So that is number one. And number two that ASM also provides is, I would say, the safety of data. How?
So we require more processes if we are distributing the IO.
Do we require more processes, CPUs you mean?
CPU means server process is taking the, it is taking the all performance.
No, see, it is a server process which gives the signal to the kernel that I need so many blocks. And then it is when the job is passed to the kernel, it is the job of the kernel to pass it to the next IO device. And then the IO device is going to do the job, and the whole information will flow in that sense. The device to the kernel to the actual UNIX process. So our server process is going to interact with the kernel, and now kernel is going to give it to the multiple, because it has to work with the two devices now. It has two of the /dev devices that we're going to look into now. Two of the disks. So server process is not going to kind of change over there.
So, sorry to interrupt. How can we differ the distribution? It's done in Linux on file level, and in ASM or
so
it's done on segment basis.
Segment basis, yeah. So now usually on the DBAs used to do this thing. DBAs would say, I'm going to do an IO distribution. So DBA will go to the system administrator and he will ask, okay, give me some space on the C drive, which is one disk, and give me the space on the D drive, and he will put one data file over here and another data file of the same table space over here. So this is the IO distribution done by the DBA, not by the system administrator, but obviously system administrator has given you two disks. Now, little later on, what happened is system administrator said that we have a mechanism to do the IO distribution, you don't worry about it. So what they do on the Unix, it is that LVM thing, logical volume manager. That's the Unix utility which will do the IO distribution. So what does it do? Let us say you have one disk here, you have another disk here, and then on those two disks you are going to create a part of this disk and a part of this disk will be created, combined together, will be called as a logical volume. Okay, a logical volume. And what exactly is a logical volume? It's logical. It is actually split on two different disks, but now we call this as our C drive. Okay, earlier we used to think that one disk is the C drive, but now this together with this is your C drive. This is how a system administrator can do with the help of any tool, like which is a partitioning tool, and LVM is just one of the partitioning tools there, but any partitioning tool you can do all this stuff. So now what happens, since our C drive is split on two disks, a DBA would just put their files on the C drive. He doesn't have to worry about, oh, am I again gonna split that? No, don't worry about it. We have already done the splitting, the striping, what we say, and you put your files over here. So file would go, some file will go over here. This another file maybe that will go over there, and then the IO will get automatically distributed. But DBAs don't have any control over it. DBAs don't have any control over it. It is just happening at the OS level. And the the distribution or the striping, that is the correct word, the striping is happening at the file level. Okay, a file typically gets some part of the file is here, some part of the file is there. But finally, inside the file there are extents and all that stuff, so I/O will get distributed. And the advantage is still there, and we DBAs don't have to worry about it. So that is done by the LVM, and still in so many Oracle shops, they do a striping like this. The striping is done at the LVM level, at the OS level, and DBAs don't have to worry about it. Okay. And now the ASM came in. ASM said, Oracle says that we will do the partition striping. Okay, that is what Oracle says. What is in my I consider that ASM is a LVM from Oracle. This is my definition of kind of saying because what does ASM do? ASM allows you to take disks, stripe the data, and ASM allows you not just to stripe the data, mirror the data also, and that is what the safety is. Mirroring that we haven't talked about. It is that safety thing. And striping. Okay. Now let us see how Oracle does it. The starting point of Oracle is you need to have multiple disks. So let us say I have disk, one more disk, one more disk, and one more disk. Let us start with 4 disks. You can have separate disk also. Let us take a simple example. This is a disk of 10 gigabyte. All of them are 10 gigabyte, 10 GB and 10 GB. Now what we are going to, in Oracle's ASM terminology, now I will talk about ASM terminology. Number 1, something called as a disk, which disk is a disk is a disk. I mean, in ASM we call it a disk, in LVM we also call it a disk, and in normal partitioning we also call it a disk. Disk is a typical disk. Then there is a concept of what is called as a disk group. Okay, disk group is a collection of disks. Okay, one or multiple disks clubbed together is a collection of the disk. So let us say now I have 4 disks to start with. I created logical collection of these 2 disks. I'm going to call this as a disk group number 1. Okay, then I can call this just one of them as a disk group number 2, and I have one more as a disk group number 3. Why am I doing this? Depending on the need of my space requirement for a database. So let us say now I have certain requirement to create a database. Let us say database is DB1, or let's take a different name, Shekhar DB. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. SDB. Okay. SDB is the name of the database. Now the requirement for this is, let us say 15 gigabytes of data is required to be stored. Now I have this disk group which can store 20 gigabytes of data. But now I have to decide one thing. Is this disk group going to be number 1, what is called as a mirrored? This is number 1. Or is this group going to be striped? So you can say I'm going to stripe this disk. So this our data is going to be striped over here. Some of the data will be here and some of the data will be here.
But
So,
which data?
which data? Okay, which data we don't have to worry about. What we do is when we create a table space, we just specify this command. We say create table space SPACE, let us say TS1, and then a semicolon. Then a semicolon. We don't specify anything here, and automatically a table space with a specific size, obviously size here is going to be 100 megabytes because ASM works in conjunction with what is called as OMF, Oracle Managed Files. We have to make sure that they work together. When we set up the OMF, and we'll see in a second how the OMF is set up, Oracle Managed Files, which means Oracle is going to manage the size of the file and the name of the file, the full name of the file. That is what OMF is. For that you need to set up a couple of initialization parameters. So once this is set up by setting those initialization parameters, a table space TS1 will be created with a default size, in this case 100 megabyte, and that will be actually the file would actually now go where? In DG1. Why in DG1? That is also set up through one of the initialization parameters. Okay, there is an initialization parameter called as OMF initialization parameter called as create DB create online, yes. DB create file dest, nah? Thank you. File dest. Now this is equal to the name of the group, DG1. Name of the group in single quotes, yes.
So DG group works like a table space and the group is like a data file. We can
no, this is going to work as a directory. So consider this as a directory. DG1 is a space. It used to be a directory earlier. Now it is just one big thing where your data file for this TS1 will be created. And that will automatically be created over there. Okay. So actually I skipped a couple of things. We'll start with the concept of a disk, then the concept of a disk group. Disk group is a collection of disks, and then you can set up the disk groups in two ways. One is the striped and another is a mirror.
But disk group is a logical thing.
Is a logical concept. Disk group is a logical concept, disk is a physical concept.
Like a table space and data file.
You can consider it that way. But I mean, don't mix and match that. But yes, you are absolutely correct in saying that disk group is a logical concept and disk is a physical concept. Absolutely correct. Now, and so, okay, so we have created this disk group, and then we come and say create tablespace TS1. Automatically a tablespace, a data file for that will be created inside this disk group. Assuming that this disk group is set up in such a way that it is striped. Okay, what happens? ASM is specifically designed for Oracle. So it is not just going to stripe the data file in half and half here. It is going to actually do the striping of the segment. Okay, it is going to, let us say you have an employee table. The employee tables, one part of the employee table would be here, another part of the employee table is going to be here. And what is that one part? And that is called as a grain. So I would say here, grain is another concept, and there are two types of grain. One is a fine grain, and the second one is the coarse grain. I believe the fine grain is coarse grain is 1 megabyte in size, and fine grain is I think 128 kilobyte. Is that correct? I need to check on this. But basically what it is, a file, especially now the control file striping happens in the fine grain, but data file striping happens in like 1 megabyte, the coarse grain. Okay, so 1 megabyte is here, 1 megabyte here, 1 megabyte here, 1 megabyte here, and that way you are guaranteed to have half of the data here and half of the data here, and IO will get distributed 50-50. Okay, and obviously IO distribution advantage. So this is going to give you the performance. Now, as opposed to that, if I say instead of creating these groups, I mean this for one database, this is for another database, and this is for another database, I can say, let me do it in a little different way. My database is so critical that I need to also provide safety, and I can provide safety using ASM also. So what I'm going to do, I'm going to create one huge disk group. Let us say that disk group is called as DG1, and then inside this disk group I'm going to create two fail groups, FAIL groups. So this is one fail group and this is another fail group. The fail group is an exact copy of each other. So if this is 10G, these two disks should also be 10G and 10G. You cannot have mix and match there, like this is 10 GB and this is a 5 GB. Because what I'm going to do, for each and every byte on this, there will be a copy of that on this disk, and same thing for this disk.
It's just mirroring.
It's a mirroring thing. So what we are doing here, we are doing mirroring plus striping in this situation.
The redo log file will not be there.
No, everything. Redo log files are also there, control files are there, all files, and data files are there. The only files that we cannot keep inside this complex ASM thing are our files that we need to read. Text files, our trace files, our alert log files. Those are the things that we cannot keep over here. So now in this situation, consider this fact that we have 40 GB. Now we have created a disk group called as DG1. How much of data can we store in this configuration? Maximum data that we can store is only 20 GB. Okay, so if you have a requirement to store 40 GB of data or 30 GB of data, this configuration will not work. So depending on how many disks you have, you can do it. Many people do some other combinations, like for example, if you have 7 disks, let us say 1, 2, I might do something like this. I might say, okay, let me create a disk group of this and one fail group over here and one fail group over here. So this is striping as well as mirroring. And then out of this, I don't need to do any mirroring. I will just do striping here. And what I'm going to do, all my data files, my control files, everything will be here, obviously mirrored on this side. But on this side, I will do my backups. Okay, I can take my RMAN backups on this side. So RMAN backups can also go inside ASM. So I can configure it in a different way. So now let us see how to create a disk group. Now, okay, before we even get into that, we need to understand how the disk groups are managed. Okay, so let us consider now this is a situation here, and we have created one disk group and maybe 2 fail groups. Okay, fail groups are gonna provide safety. Now Oracle says that this is a complicated business and we are going to have certain set of programs or certain set of processes to manage the data in this thing. There are so many things that go inside this thing. For example, if a table comes in, it has to kind of get split and half here and half here. No problem. Another thing that has to be done, let us say this becomes full. Then what do? We add a third disk here. The moment we add a third disk here, we have to add another disk over here also of the same size. The moment we add those disks, what is going to happen? Our data is not evenly distributed now. It is here, but not here yet. So Oracle internally does something called as rebalancing. Rebalancing is the process where part of the data from here is now shifted over here and part of the data from here is shifted over here. The goal is to distribute it evenly across all the disks inside a disk group. That is what a rebalancing thing is. And this can happen when our database is online. Okay. Without shutting down the database, this rebalancing can happen. And obviously, when the rebalancing is happening, the performance is going to be slow. It's going to be bad. And there is an initialization parameter called as ASM power limit. Is ASM there or just power limit? ASM power limit. The value of this can range from 1 to 11. 1 means the slowest act of rebalancing and 11 means the fastest act of rebalancing. So obviously if you put 11 for this parameter, then rebalancing would happen very quickly, but during that time when the rebalancing is happening, the performance of all of your queries and inserts updates would be slow.
So can we treat these systems as hot swappable systems then if we are adding it without checking the data?
Yes. So 24/7 support can be achieved by this. And obviously if this disk, something goes wrong with the disk, our database is still running. And then you add another brand new disk and the rebalancing will happen. That is the key.
So only 1 and 11, this is the...
1 or 11, 1, 2, 3, 4, 5, 6, all the way to 11. 1 being the slowest, 11 being the fastest. It is the speed, yeah. It is the speed at which, I don't know, they have just given it in units. I don't know exactly what speed it happens, but the slowest and the fastest. So that is what rebalancing business is, when you add or even remove a file. Remove a disk. If you remove a disk, all the data on the disk has to be now put into the remaining 2 disks.
Yes, if one of the payload is corrupted, then other payload will take space of it, or the processes will refer other payload, which is good.
Say that again.
If one of the fail group gets corrupted,
the whole fail group.
Yes.
Okay.
Then the processes will refer.
Yes. If this one fails, it will go to this. If this one fails, it is actually going after one of them, and if it cannot find data over here, it will go to the next one. While writing also, the writing also, DBWR will write to kind of one, and then internally the ASM mechanism, the process of ASM will make sure that it writes to the other one. So the speed will not, otherwise DBWR has to write at 2 places. So that is what the rebalancing is. And now Oracle says that to manage this whole complicated business, we have a set of processes, the program which are running, and we also need certain memory for that. And therefore, since the memory is required and the set of processes are required, we again call this as an instance. But we call this as an ASM instance. So an ASM instance is a memory plus the processes which will manage this whole complicated business. And there is and another thing I believe what Oracle has done is there is a process called as LGWR. There is a process called as CKPT, I believe. And all these DBWR. But there is another process called as RBAL. RBAL is the process. So RBAL is the one that does the balancing along with some other slave processes called as ARB processes. ARB are slaves one. I am writing it so below that I don't think anybody can see it. So ARB is the process which will actually do the rebalancing, and the master is RBAL. The master process is RBAL, rebalance. So my take on this thing is, why do we need checkpoint process? Why do we need that LGWR process for the ASM instance? Because it is really not a database instance where you have the control file and the log file of its own. Because checkpoint is required for a checkpoint process. So I believe Oracle has already used the source code that it has developed for the RDBMS instance to manage these kind of things. But in reality, this SGA will not have the log buffer, redo log buffer and all that stuff. It will not have any other things, but it will have definitely something called as a large pool for its internal purposes. So this SGA is usually very small. By default, I think it is like some 70 megabytes or something. Okay, you can give the large pool value to that. So what we need to do, we need to first start with the disks. The disk has to be given to us by our system administrator. Let us say all of our disks are called as /dev disk1 /dev disk2 and so on, and we have disk till let's say 6. So that is our starting point. Once we have that, what do? Is we create an ASM instance. Okay, the first thing, all these disks, the owner should be Oracle. Okay, owner should be Oracle, group should be O-install. So you need to ask your system administrator to give you this permission, or this chown command has to be executed here. And then you need to start creating the ASM instance. So step number 1 is create ASM instance. Now I will not go into details of creating the ASM instance, but basically you have to create the bdump, cdump, udump directories and the p file directory, and the most important thing, you have to create the p file for the ASM instance. And the p file for ASM instance will not have too many parameters. I will just mention 2 of the parameters which are important there. Number 1 is the instance type, and instance type is ASM. Okay. Instance type is ASM. And then another thing, maybe large pool. You can specify maybe 128 megabytes. Otherwise default will be taken. And yes, disk.
DB unique name.
Yes, DB name, na?
DB
unique name. This is the name of your ASM instance, and usually by default it is plus ASM, doesn't need to be plus ASM, but that is the standard, the name of the ASM. And then there is one more called as disk string. Is it DB disk string?
ASM underscore.
ASM yes, thanks. ASM underscore disk string. This is the list of disks that the DB has, the system administrator has given to you. So here I'm going to write in single quote /dev /disk1, then single quote complete, and then again /dev /disk2 single quote complete, and so on and so on. So if you have 8 disks, you will be typing this a very long string here. This tells you that we are creating an ASM instance, or ASM whole, the phenomenon, that's what I would call it, with these many disks. How many disk groups we're going to create, we will decide that later, but this is what we're going to have in our whole ASM storage device. Okay, and then there is ASM disk group. This is, let us say, DG1, DG2. Oh, sorry, the names are usually plus DG1 and plus DG2. All the names. See, in Unix, everything starts with a slash. In ASM, everything starts with a plus sign. Okay. So, what is the meaning of ASM disk groups here? ASM disk groups are basically the names of the disk groups that we have created from these disks, which will get mounted. So, this is a list of mounted disk groups. Mounted disk groups, and the meaning of mounting is different here. It's not like our database getting mounted. The meaning of mounting is that those disk groups are now available to the RDBMS instance, so that RDBMS instance can store the files over there. So whatever instances, database instances that we were creating so far are now classified as RDBMS instances as opposed to ASM instances. Okay, so we have an ASM instance. I will again draw the same diagram. This is that disk group, let us say DG1, and then the ASM SGA is there, and the ASM processes are there. So this is all ASM business. And now on this side we have the SGA for our RDBMS instance. So obviously you have buffer cache, you have a shared pool and log buffer and so on, and the own DBWR process, own LGWR process, all those things are here. And now instead of having its own disk, it is storing the information over here. So my data files are here, my control files are here, and my redo log files are also there, except which files are on this side? The alert log, and the P files, and basically the text files. The text files that we need to read would be on the outside, trace files and all those things. So that's why now we call this as an RDBMS instance and this is the ASM instance. Now we say that ASM instance is a service which provides is a server side and this is a client side. This ASM instance provides a service to the RDBMS instance. The service is of the storage. Now another great thing is that it is not just one RDBMS instance which can utilize this storage. Another RDBMS instance with a totally different name, with a totally different set of processes and SGA can also go and store its own data in the same ASM instance. That is the next thing. So ASM becomes now something that does a storage management. And we don't have to worry about all that stuff. The striping is done by ASM, the mirroring is done by ASM, so safety and performance is taken care by the ASM. All we need to do is make sure that we create data files over here. And to do that, as I said, OMF has to be implemented on this side. Okay, and in that OMF, earlier we used to put what? We used to put the names of the directories. That parameter again, what is that parameter? DB create file dest. Create file dest is equal to plus DG1. So all the data files will go in this DG1. Okay, that is what it is. DB online create file dest. File dest is equal to, you can specify DG2 if you have a DG2, and you can specify the flash recovery area, which is DB recovery, DB recovery file dest as DEST as maybe plus DG3. Okay, so you can specify all these different things. So this is what I would say implementation of OMF is. This is what OMF is. And then things will be alright.